What's up, my mathletes? This is Mr. Muscarella coming at you, and I'm going to show you how to find the reference angle without sketching the reference triangle, without actually drawing the angle and sketching the angle. Now, you know that you need to know how to sketch an angle, but I'm going to show you a way to do it without actually sketching it. So let's take a look at a couple examples here. Now, these ones are going to be the ones in radians, right? So radians is going to be a little bit different than degrees, but our idea that we're going to use behind these is going to be very, very similar. Now, the key thing that you want to remember on this, so we're going to first we're going to convert these to radians. Now, we know 0 is just plain old 0 radians, so we don't have to write a pi with that because 0 is just 0. 360, we know that that is 2 pi. Now, notice the difference in those two. So if you think about it from a unit circle perspective, if I went around once, I went around 2 pi. If you go around again, you'll go around another 2 pi. So that would give us that 720 degrees or 4 pi. And then 1080, we would just add, go around one more revolution. So that would be 6 pi. Now notice everything on this side is separated by a factor of 2 pi. So every time we went up from 0 to 360, we increased by 2 pi. 720, we went up another 2 pi, and so on. So all the even multiples of pi are on the right-hand side. Now on the left-hand side, we know that 180 degrees is pi. Same idea with this. If we started here, right, and then went around, we would still go 360 degrees, and we know 360 degrees is 2 pi. So we're going to take that 2 pi, and we're just going to add that now to 1 pi. So 2 pi plus 1 pi is 3 pi. So 540 is 3 pi. And then 900 would be another 2 pi, which is 5 pi. And 1260 would be 7 pi. So those are going to be kind of our standard ones that we'll use when we're working with radians, all right, all the time, all day, every day. Now the challenge with this is going to be working with the radian when we have a fraction, right? Because a lot of people get stuck on this. So here's how I want you to kind of analyze this. We're going to look at what I call the magic number, and our magic number is 4, right? So we know that pi is going to be the same thing as 4 pi over 4. Now 0 is just 0, so we don't even write anything. That's just 0. We don't put a 0 pi with it because 0 times pi is still 0. 2 pi, so that magic number 4 pi, if you take 4 and double that, you'll get 8 pi over 4. Notice if you reduce that, that would get you down to 2 pi. And 8 pi is kind of another magic number, so you could kind of think about that too. If I added going vertically, if I added going down and continued, 4 pi would be the same thing as 8 pi plus 8 pi is 16 pi over 4. And notice if you reduce that, that gets you down to 4 pi. Same idea here. 6 pi would be the same thing as 24 pi's over 4. All right, that's the right side. Now on the left side, again, same thing. We would add 2 pi, or in this case, 8 pi's over 4. So if I look at the 4 pi over 4 and add 8, I would get 12 pi's over 4. Here we would end up with another 12. Adding 12 and 8, we would get 20 pi over 4. And again, that reduces down to 5 pi, so we're good. And then, of course, when we find 7 pi, we could either add another 8 pi, or I'll show you another way to do that. So that'd be 28 pi's over 4. Now, another way you could do this, right, is take that magic number, which in this case is 4, and you can multiply it by whatever number's in front of pi. Because 4 times 3, check that out, bro, that's 12. 4 times 5 is 20. 4 times 7 is 28. Same thing on the other side, right? If you had 4 times 2, that would be 8. 4 times 4 gives us a 16, and 4 times 6 gives us 24. So that's going to be the first thing, is getting our multiples of pi, or 2 pi, in terms of our denominator. That first magic number. All right, so from there, what we want to do is find out, same thing as we did in degrees, right? We want to find which one is closest, which value is closest to 11 pi over 4. And that would be 12 pi over 4. So again, notation is really key here, so make sure you write reference angle with the correct notation. So our reference angle would be the absolute value of our quadrantal angle, which in this case is 12 pi over 4, and then minus our angle that we're given, 11 pi over 4. When we do that calculation, we come up with 12 pi minus 11 pi gives us 1 pi, and we don't have to write a 1 in front of it, because that's what we do in math. So we'd get 1 pi over 4. All right, so that's how you do that. It's just that simple. All right, so that's example number 5. Now we're going to apply that same principle here, so let's take a look at example number 6 here. So example number 6, we're going to take that same idea that we just had with multiplying everything multiples of pi. We're going to do that same thing here. So with 180, and again, I want you to just write this down so we know that's pi, we know that's 3 pi, and if we don't know, we're getting there, right? Because we're going to develop those patterns. And now we have 7 pi. On the right side, we're going to have 0 pi, or just 0, 2 pi, and then we're going to have 4 pi, and then we are going to have 6 pi. So those are our values that we'll start out with. Now, on this one, right, magic number, so our magic number in this case is going to be 9, because 9 is my denominator here, right? So what I want to do is start converting everything so that it's something over 9. And again, which way you do that is completely up to you. I'm going to do the multiplying method here for this one. All right, so there's going to be, we got our magic number of 9. So we're just going to go through. And again, I'm going to go vertically this time. So I know that pi is going to be the same thing as 9 pi over 9. And then 3 times 9 gives me 27 pi over 9. Again, that reduces all the way down, right, to 3. So we're good. And then 9 times 5 is 45 pi over 9. So that's the same. And then 9 times 7 is 63 pi's over 9. So that's that left side. And then we do the same thing going over on the right. And we would get 2 pi is the same thing as 9 times 2, 18 pi over 2. And 4 pi, 4 times 9 is 36 pi over, oh, I almost said 2. I meant 9. I'm thinking too fast here. And then 6 times 9 is 54 pi's over 9. So those would be the values that we would use to help us figure out what our reference angle is, right? Now, 34 pi is really close. So this is where you kind of, you might have to do some arithmetic here and there. But if you look, it's like, wow, that's only like 2 away from 36. That's pretty cool. So again, reference angle, notation correct, absolute value of 36 pi over 9 minus 34 pi over 9. And you would end up with, of course, a value of 2 pi's over 9. Now, every once in a while, you might, like, say we ended up with 3 pi over 9, then we just got to reduce it. And that's that. So again, take your magic number, convert all your multiples of pi into the correct ratio, and then set up your reference angle correctly using correct notation, and you're ready to roll, bro. You got this stuff. Now, there's 2 other ones here, and I want you to try these 2 on your own, right? Number 7 and number 8. So I want you to pause the video, do your converting, and then come on back, and let's see how well you rock this stuff. All right, so let's first take a look at number 7 here, right? So 6 is our magic number, of course. That's going to make this 6 pi over 6, and then we're just going to take a look at 2 pi, so, 2 times 6 is 12, right? 2 times 6 is 12, so that's 12 pi. 4 times 6 is 24. You guys get the pattern, right? 6 times 6 is 36, and same thing here. 7 times 6 is 42. 5 times 6 is 30. 3 times 6 is 18. So that gives us all of our numerators. And again, which value from there, from our 2 columns, is closest to negative 13 pi over 6? And again, when you have the negatives, don't forget, just ignore that negative sign. Just don't even worry about that. All right, because what we're going to do is we're trying to find that distance between our reference angle and the x-axis. So when we do that, we get 12 pi over 6 minus 13 pi over 6, and that's just 1 pi over 6. Boom, we're good. So remember, your answer can never be negative. So you can't come up with a negative pi over 6 or a negative whatever. It always has to be between 0 to 90 degrees, right? And that's in degrees. But in radians, that's 0 to pi over 2. And if you're talking about our magic number 6, right, because we want that to be the same thing, we want a denominator of 6. So that would be the same thing as 3 pi's over 6. So it's got to be between 0 and 3 pi over 6 in this case, because 6 is our denominator. So it's got to be between 0 and 3 pi over 6, and pi over 6 is cool. So that's example number 7. Let's check out number 8. Now again, with this one, we've got the negative 49 pi over 18. So 18 is our magic number. So hopefully you did all right getting those fractions there. I know they're going to be a little bit bigger, but the value that is closest is 54 pi. So we're going to get 54 pi over 18 minus the 49 pi over 18. Now again, degrees were between 0 and 90, but on this one, right, with radians, 0 to pi over 2. Well, if that's got to be over 18, what's half of 18, bro? That's 9, so that'd be 9 pi's over 18. So again, check ourselves before we wreck ourselves. Is our answer between 0 and 5 pi over 18? Boom, diggity, done. Yeah. All right, cool. So hopefully with all that now, you totally are owning and rocking finding reference angles without even bothering to have to do the sketch. All right, but do make sure you know how to do the sketch because that's a whole nother skill in there, right? Cool. So you guys have a magnificent day, evening, morning, wherever you're at. I'll catch up with you soon, man. Peace out.